between security guys and business leaders end up in the boardroom and always end up in the same way. The security guy goes to the business leader and says, I need more money. Why? Because we need more security, we need a bigger budget, because we need more infrastructure, we need better security software, we need more people, right? The biggest problem in cybersecurity right now is finding the right people to fill in the slots. So for the first time, just a couple of weeks ago, we see these two numbers, cyber leaders and business leaders, who practically share kind of like the same vision on how cybersecurity incident could be impacting their organization. And that's important. Some other stats that came out of that survey, or report actually, involved around the fact that organizations, about 44% of all organizations expect geopolitical risks to substantially affect their cybersecurity strategy, right? So they're worried about everybody. It's not just small, medium-sized businesses and large organizations, but everybody pretty much expects that the current geopolitical context is likely going to influence their cybersecurity strategy for the next 2 years, whether it's a global cyber attack, whether it's a targeted cyber attack, it doesn't matter. What's even more interesting is that if you break this number down into how SMBs and how large organizations perceive that risk to their organization, it's again interesting. 40% of SMBs expect geopolitical influence and stability to have a substantial influence in the likelihood of confronting a catastrophic cyber event in the next 2 years, compared to 58%. First glance, it's not a big difference, right? It's about 10%. Now, if you think about it, it's kind of misleading because this perception does not actually reflect reality if you look at how data breaches actually occur and the reason for why they occur. And I have a slide where I'll detail more about that, and I'll come back to this. So we've basically seen how cybersecurity leaders and business leaders perceive the global threat landscape. We've seen how SMBs and large organizations, again, perceive how a cybersecurity incident will be impacting the organization. But what is the actual reality? Well, if we're looking at our own threat telemetry, if you will, about 30% of malware out there is compiled or is accounted by compiled executables, PE files. Now the rest, 70%, is non-PE. They're fileless, they're scripts, pretty much everything you can throw at an endpoint that bypasses traditional security solutions. And that is interesting for the simple fact that if you break down the file types for non-PE malware, and you then take a look at the most prevalent non-PE malware families, you'll see that PDFs, Python, CDF, zips, and whatnot, these are the most prevalent file types that are most likely to be abused by fileless threats. Why? Very simple. PDF also supports, for example, JavaScript. Documents support VBS, macros. You can run PowerShell out of a boatload of files. The most prevalent malware families have to do with, for example, in blue, 29% is PDF capture, and according to our not so recent telemetry. If you think about it, PDF capture, you've probably heard about it, right? It's mostly used in spear phishing campaigns, phishing campaigns. You get that little email with an attachment saying, hey, you've just won, I don't know, you've just won an award. Click here to get your voucher, your redeem code, or prove that you're not a robot or a machine. As soon as you do that, because it is a PDF file type, it has the ability to execute additional code that has been embedded into that PDF file. And remember the slide where I told you, the previous slide where I told you that the perceived SMBs and large organizations perceive that they're not, how they will be impacted by a cyber attack. According to the recent IBM cost of data breach report released, I think a couple of months ago, about 83% of organizations have suffered a data breach in 2022. 76% of SMBs have been impacted by at least one cyber attack, and 20% of breaches occurred because of a compromise at a business partner. Now, what does that tell us? It pretty much tells us, when 20% of breaches are compromised by a breach at a business partner, we're basically talking about SMBs. We're basically talking about small and medium businesses that, according to our previous stat, do not perceive to be at at such a high risk as large organizations, although the actual reality is that SMBs can usually be used as an initial attack vector for adversary to pivot into larger organizations for which they offer services to. Now, again, this is the main difference that I wanted to point out. The way cybersecurity is perceived and the way reality actually looks like. And if we're looking at reality, 95%, so last year, I think, we've seen a 95% increase in cloud exploitation cases compared to 2022. And this is actually a number that's been presented in our recent Global Threat Landscape report. It was published just yesterday. So if you haven't had a chance to take a look at that, go ahead and download it. It has tons of information. And we've seen that the number of adversaries that have picked up TTPs, tactic, techniques, and procedures to target cloud environments has increased threefold in the past year, right? So that means if you're looking at this, what do you see, right? You're seeing more breaches. You're seeing SMBs used as an initial attack vector and as a way to pivot inside larger organizations. And you see 20% of these breaches have been caused by SMBs. And you see that most of the infrastructure, I don't know, you can blame it on the pandemic if you want to, right? Everything is now cloud-based, and adversaries have shifted their focus, right, to start targeting cloud infrastructures because everybody's using it, whether it's an SMB, whether it's a large organization. So these four numbers actually tell the story of the entire threat landscape as we've seen it today. What does that all actually translate into? Well, it translates into cost. So if you're a business decision maker or a cybersecurity leader in an organization and you've had a data breach, the first thing that you're going to be thinking about, how much money do I have to spend to make this problem go away? Or how much do I have to invest to make sure that this doesn't happen again? And the cost of a data breach has recently been estimated at about $4.36 million in 2022, which is about 13% increase compared to 2021. It's not a lot. However, for the US, the cost of a data breach is actually twice as high than the global cost of a data breach for everybody else, right? It's $9.44 million for a potential data breach. Not a potential. If you've suffered this cost, it's an actual data breach, sorry. I mentioned that we're going to be talking about some examples. So I mentioned that 30% of malware out there is PE, while the rest, 70%, is non-PE. Now I'm just going to use two examples, one for Windows and one for Mac. This is based off some of the most recent research that we published on the CrowdStrike blog. If you've never seen it or if you've never checked it out, please go ahead and do it. We post a lot of interesting research out there, whether it's adversary-related research, whether it's data science research, whether it's threat research. It's a good place to find interesting stuff. Thanks. I picked GULoader because GULoader has been under active deployment and constant, not active deployment, under active and constant development. And the reason why it turned out to be such a popular tool is because it's used as a downloader to bring to the endpoint additional other pieces of malware like ransomware, like keyloggers, bots, and whatnot. What's interesting about it is that it directly, so as early on in the kill chain, it employs a series of tactics and techniques associated with fileless attack. For example, it uses a visual basic dropper that drops a payload into a registry key. Then it uses PowerShell to unpack and execute that payload directly within memory. Completely bypassing any file-based detection solution that has to do with looking at files that have been written to disk and then analyzing them. This technique of daisy chaining, Visual Basic, PowerShell, WMI, or any sort of scripting language has become very popular, widely adopted, whether you're talking about ransomware, whether you're talking about a cryptocurrency miner, whether you're talking about a downloader or even garden variety malware, any other type of garden variety malware. And what that says is that if you're strictly thinking of detecting threats from a PE point of view, you're going to miss out on a lot of interesting stuff that's been going on. Now, the second example that I wanted to show you is that this is not a problem that's endemic for Windows. It also happens to be present for Mac. For example, for Mac OS, you've got binary file and non-executable. This is not binary, it's supposed to say non-executable files, which pretty much involve everything that have to do with DMG files, packages, Office documents, applications, and the regular scripts we're talking about. Bash, Python, AppleScripts, Perl, and whatnot. Some of the most popular malware families recently that have been using these non-executable binaries revolve around EvilQuest, for example. That is a popular ransomware family that's been known to abuse both DMGs and packages. It's been known to also use a boatload of scripts, mostly to ensure consistency on the machine once it gets there. And if you're thinking ransomware is not such a common problem for macOS users, think again. There's a lot of folks out there that usually want to disable the built-in security mechanism for Mac that doesn't allow you to download applications or install software from third-party marketplaces. And when they do that, they're immediately exposing themselves to risk. We've seen campaigns that usually have to do with Schlayer. If you're familiar with Schlayer malware, that is, what are you laughing? You know about Schlayer.
I had a lot of work to go on Schlayer.
There you go. Right. So we've seen malvertising campaigns that have to do a lot with fileless techniques, Schlayer being one of them. So the point is, regardless if it's Windows, Mac, or Linux, that ratio, 30 to 70% PE to non-PE malware, is kind of constant across all platforms. So you can almost say that malware or non-PE malware is platform agnostic at this point. Now, what is the solution to all this? I don't want to scare anybody, although scare tactics are good. But there is a solution. There's always a solution to a problem. And the way we've approached this is by using machine learning and artificial intelligence, which is if you break it down to its most basic concept, it pretty much involves the ability to analyze large volumes of data with speed and accuracy, the ability to uncover patterns in that data that may be hidden to the human eye, and ultimately, all you want to do is automate repetitive manual tasks and service high priority detections of data. So if you want to sum up machine learning and artificial intelligence in a way that even your grandmother understands, basically, you use these 3 steps to make sure that they get what machine learning is all about. If you want to break it down as if you were explaining it to Marion over here, it's a data science picture. You have this input, X, Y, Z. You create a function which describes the behavior. It contains various behavior characteristics for the input, which is basically a function, and the outcome would be to be able to make a prediction based on a data set. What AI and machine learning is not is 3 things. Number 1 is not intelligence. So don't think Terminator, don't think Skynet. So it's not self-aware, but it does provide algorithms and techniques for solving hard problems that would take a lot of manpower and time to solve. It is not a silver bullet. So that means that you cannot use AI to pretty much solve every other problem out there, right? But it can do, and it does that very well, it can analyze large volumes of data with speed, scale, and accuracy, something that we humans very much suck at. Number 3, AI is not replacing analysts, right? So there's a lot of talk that AI will be taking over everybody's jobs. Some jobs potentially will become obsolete, but that doesn't mean that there isn't room to grow and expand in other areas, right? Everybody has to, at some point, 10 years ago, think about it. 10 years ago, there was no such thing as a social media manager, right? With the invention of social media, we now have jobs that have to do with social media. So AI is not replacing analysts, but it can enable automation for repetitive manual tasks, right? So it can become a tool to help you become better at your job, basically. I'm going to stop here with explaining machine learning because I'm going to ruin it. And I'm going to leave it to Marion to tell you more about how we implement machine learning across the breadth of our technologies across CrowdStrike.
Cool, thanks. I thought I was growing roots. All right, so like Libby said, I mean, one thing that we want to do with AI is basically remove the scale out of the equation for our expert analysts, right? So we use AI across the entire CrowdStrike. And what I mean by that is we deploy AI on the cloud, we deploy AI on sensors, we have behavioral ML that look at the event in real time and then provide a solution. And of course, we have expert machine learning that helps specialized teams like Intel, Overwatch, Falcon Complete to give a solution to the client. And even more than that, even before a sample or an attacker gets to the sensor, we do have an AI model or an AI solution, basically part of Falcon Identity that looks at logins and tries to understand based only on login attempts whether somebody used a compromised password, somebody is trying to hack into the box and cuts that attack's legs, let's say, from the get-go.
Basically trying to figure out if there's any anomalous login behavior. Think of it like that.
Yeah. So, like I've said, tens of models that we've deployed on multiple platforms, and I'm talking here about Windows, OS X, a lot of versions of Linux, because there's a lot of them. As an example, our ML model for Windows, the on-sensor model, has about 40 megabyte, which is, I think Libby was joking, like the same size as the actual rest of the code base. And in terms of numbers, on Windows, we have 99% of the pre-execution or the malware detected pre-execution, so it doesn't even have a chance of running. And we have a lot of third-party testers agreeing that we provide 99% detection coverage. We have results from third-party testers like A/B test, A/B comparatives. There's so many, I don't remember all.
So 99% detection coverage using ML, machine learning, right?
Yeah.
So no scanning engines, no behavioral scanning engines that are built into the sensor. So that's why I made the joke that 40 megabyte sensor, or close to 40 megabyte sensor, is a really small footprint to have as a security vendor, while others potentially have hundreds of megabytes of.
It's interesting to know that this is the largest, like Windows, just because there's a lot of attacks out there for the platform. The model tends to be a bit larger, but models for on-sensor Mac or on-sensor Linux are much, much smaller.
What that says is that you can get the same output, the same outcomes in detection efficacy by using a far more optimized solution, right? Using machine learning.
So, in a nutshell, the way we basically process data and build or use our machine learning models in order to provide protection to our customers is by retrieving feature vectors and metadata from our sensors. And when I say sensors, I mean servers, laptops, even handheld devices like iOS. Everything goes to the cloud. In the cloud, we have our machine learning model that take this data, process it, and provide feedback to our CrowdStrike analysis teams that use this data in order to provide a definitive answer. Yes, this is an attack, or yes, this is your malware campaign that we have been able to pinpoint, or clean sample. These are later used to augment the corpus for our machine learning models, and whenever we train a new version, these guys don't need to look at the same attack over and over and over again. And that's why I said, like, we are trying to get that volume problem out of the equation for the analysis teams, so that you don't need to analyze and review the same attack over and over again. We're not 100% there. I don't think we're going to be anytime soon, but we're chewing off every week more and more.
So remember when I said that AI will not be taking your job very soon?
Yeah.
It's not going to be taking your job very soon because you still need human in the process to offer that feedback, whether
Yeah.
it's a dirty or malicious sample, so that you can retrain the model to make it better each and every time.
That's correct. One of our tools, frameworks that we're very passionate about is our AI-powered indicators of attack. So what AI IOAs is, basically, it's a cloud detection platform that allows us to take events, behaviors, generally speaking, from the sensors, analyze them with AI in the cloud, and then in real time provide an answer back to our clients. This is very different from existing on-sensor ML due to the fact that on-sensor ML is having its ML model on the sensor, and that gets updated, every few days. And traditional cloud security, where in order to make any prediction in the cloud, you will need to either have the files already in the cloud or the metadata already there processed and decisions made asynchronously and then made available in case you find that metadata again and you want to provide an answer. What AI-powered IOAs does is allows us to provide an insight or a detection to our customers, even when we only see one particular event or one particular file once for the first time. It has prevalence 0, or in this case, seen it once, 1. Right? And that's basically the most powerful framework that we put at the disposal of our clients, and it's powered by AI.
And that pretty much sums up the power of the cloud, right? So if you've seen a file, even if you've seen it just once, you can extract all the relevant information from that metadata from that file, and you can compare it to the breadth of our threat intelligence that's in the cloud, and compare it to what we've seen on millions of endpoints.
It was the initial design and the root of the name of the company, the power of the crowd to strike against malware. So I started my career as a malware analyst, right? And even then, like X numbers of years ago, what happened is that malware was trying to evade detection. Back then we had signatures, right? And malware started by, let's say, they didn't start at the entry point of the PE anymore. They were hiding after the first few bytes or randomly in a function somewhere. Then we had polymorphism, then metamorphism, then runtime packers. There was a over and over this cat and mouse game. Like if you're talking with like old AV guys, they will tell you like this is a cat and mouse game. What we want to do here with our adversarial framework is we want to be both the cat and the mouse, because even before this, we went a bit too fast with it, because what I wanted to say is that the same game of evasion happens not only on signatures, but happens also on so now attackers are trying to bypass machine learning provided protection, either via finding vulnerabilities in frameworks. For example, we know that Google provides TensorFlow for whoever wants to do neural networks and deploy neural networks. They do not, however, provide assistance to TensorFlow issues because they don't consider it production-ready code. So, like in the past couple of years, there's been more and more vulnerabilities, for example, in TensorFlow that haven't been fixed. So I just want to plug our TensorFlow to Rust framework here. So for that particular problem, we've already had 2 blog posts about, and we are about to release the TensorFlow to Rust to everybody, make it open source. So stay tuned for another blog release on that. But coming back to the model hardening, we want to take the fight back to on our own grounds. We don't want to wait for the attackers to find vulnerabilities in our systems. We actually want to find those vulnerabilities ourselves before an attacker gets the chance to do it and fix it. So we've invented and built this adversarial framework that at its core takes an arbitrary file, either at random or something that the user is giving it, leverages a adversarial configuration that basically highlights the number of adversarial changes that should be applied to that file. So in case it's a PE, let's say add some data to 0 byte, or actually add some data to code case, or if it's a PDF, rotate the image inside the PDF, or if you have a script, randomize variable names. Right, so this would be the adversarial configuration, and with the adversarial configuration, it goes through our API. What the API does, it will, based on rules that our experts have been writing, make these changes, generate new files, test our classifiers, one or many, against these new files, and generate a report. That report is going to help us identify weaknesses on our models before attackers get to leverage those weaknesses or discover them for themselves. And in the next slide, I want to talk a bit about what the adversarial framework can do. So this is just like a very, very short snippet of what we support. But like I said, we support Linux, Mac, Windows PEs. We support MS Office documents, Word, Excel, PowerPoint, URLs, scripts, VBS, PowerShell, Python, Perl, AppleScript, and very, very few examples because this is a one slide. But I'll take the URL as an example where, depending on how you're doing the feature extraction in your URL scanner AI model, you might care about the sequence of the key value pairs, or you might not. In the case you're caring about the sequence of the key value pairs, if we randomize this sequence, it shouldn't affect the outcome of that URL, but it would affect the outcome of your ML model. So these kind of changes we can make to the input in order to test the generalization of the model. So going forward and going back to the adversarial framework and how we generate attacks, once we have the modification report, we are able to assess the strength of the classifier. We are able to see, okay, we are having a big problem with certain classes of attacks. So then what we will do, we will take those attacks, generate even more samples, and use those samples in training for that classifier. What happens is that now we are helping our model generalize better for those type of attacks. And when we see in the field those attacks being used against us, we will not be vulnerable to them. And I will have a slide where you can see very clearly that this works, and it works super well. Continue. So this is an example of a classifier that wasn't trained with the adversarial samples. And we put this classifier to detect a bunch of samples that we've generated using the adversarial framework. So let's say, I don't remember which classifier it was, it's not relevant, but let's say it's our URL classifier. And we didn't train it on adversarial samples. We gave it a bunch of adversarially generated URLs and asked it to generate a prediction. So ideally, if this would have been a hardened classifier, the expectation would be that all the points, all the decision values would be on the diagonal from 0, 0 to 1, 1. So no change whatsoever, right? Or even better, everything will be in the green part, meaning that this URL that was generated adversarially and was sent as the input to the classifier is now having a worse prediction in terms of it being clean. Actually, it's considered to be malware, right? So green means it's now having a higher probability of being detected as malware. But in reality, you see a lot of points are in the red zone, meaning that, again, as an example, if this URL had 99% probability of being pointing to malware, now after the adversarial attack against that URL, like I said, changing the order of the key value pair, it's considered to be clean. Like 0.0 is the decision value, which equates to a clean decision. So here you see the power of the adversarial framework. And then in the next slide, you see what happens when you include adversarially generated samples into the training. So the green graph, it's the basically the rock plot of the model without adversarial samples. And this is what happens when you train the model with adversarial samples in a test against adversarial samples. Not against the same samples that we trained it with, of course, but with other samples, because we can combine different attacks together. So if you have like 3 attacks, you can generate 1 attack with each, 2 attack with 2 of them, and 1 with all 3, right? And the cherry on top, and what I promised you, it's really an assessment that we run. I think this was done in about an hour. No cherry picking whatsoever, just choose top 100 ELF samples with a number of vendor detects, top 100 macro samples, and top 100 PE samples that day with a number of vendor detects. Put them through our adversarial framework. I think we let it run for about 10 minutes. And we asked about 5 random adversary generated samples for each file, and then look at the worst results. So you can see that for ELF sample number 1, initially starting with 17 vendor detects, by only changing in place, so by only editing less than 600 bytes, we were able to almost make it fully undetected for those vendors. So 15 out of the 17 vendors dropped their detection. And the same story over and over and over again. Again, no cherry picking, nothing whatsoever. This took an hour of our time, actually of AWS's time, because it's completely automated. We just click a button and look at the results. And yeah, I really wanted to point out at the basically the state of the industry. Everybody is testing their signatures, everybody is testing their code base against vulnerabilities, but not a lot of folks are testing their ML models against bypasses, against attacks. A lot of frameworks have started appearing on GitHub on attacking AI models, and we looked at those. We've incorporated some of those principles into our code, but it's fair to say that we have the most mature framework out there.
And what you're saying is that it's a lot easier to reshuffle Linux malware features to make it undetected.
Yes. Yeah, which is, in my opinion, it's a sad state of affair, because Linux is the backbone of the internet. PE is a bit better, AV vendors have been doing PE malware detection for 20 years, so let's say they have more experience. If you have a Mac laptop, don't think you're safe. Proof here.
Right. Yeah, so it's a lot easier to bypass Linux detection. But we've already taken up too much time, so we'll just conclude with a couple of takeaways. Number 1 is, before you start building any machine learning model, before you start building any detection mechanism, especially if you work in the cybersecurity industry, right? You got to know the threat landscape. So you got to understand what the threats are, how they behave, not locally, on a limited data set of endpoints, but also need to understand how they act and behave on a global at a global scale. And for that, you need a lot of telemetry. But the whole point is know the threat landscape so that you know what you're building protection from. Detection. The second thing, machine learning models need to have high detection, coverage, and efficacy in terms of detecting the current threat landscape. What that means is that, and Marion can speak better than I can about this, it's that it's very difficult to balance detection. What false positives means is wrongly detecting a malicious file as clean, or a clean file as malicious. So it's very hard to balance efficacy, the ability to say with 99% accuracy that the file is malicious, with the fact that you're about to incorrectly tag a clean file as malicious. And that is important because if you tag a clean file as malicious, then there's all sorts of automated procedures that kick in who do containment, remediation, put the endpoint in lockdown. There's costs attached to that. Costs in person hour. An IT guy with glasses like we do has to show up to that computer, put it back online, reinstall the operating system. There's downtime that causes the company to lose money because the server is not running because of an incorrect detection caused by an incorrectly trained machine learning model because you did not understand.
Yeah. On top of that, one of the main reasons why we built the adversarial framework was to improve the generalization capacity of our models. So not only we want to discover the flaws of our models before attackers do, but at the same time, we want our models to generalize better by giving it examples that are likely to be seen in the field that we don't have yet. Right? So if you're thinking about image recognition, right? You can use the same image, rotate it 90 degrees, 45, 180 degrees, and that's going to be a new input data for your model. You can train on that as well as another example. It's a bit more difficult to do that with files, with binaries, because you can't rotate the binary. You can, if you want to swap code, you need to do it in a way that that's still executable. You need to fix in the code in order for that to be still runnable and achieving the same behavior. So that's what the adversarial framework does. It's a way for us to improve the generalization of our models and at the same time discover vulnerabilities in the detection capacity of our models before attackers do, because let's be honest here, we know that attackers are testing our tech and they're looking forward to find a vulnerability that they can.
We've taken up twice as much time as we had planned. So Q&A, got questions now? Otherwise, you're the next runner-up to do the next presentation. Otherwise,
How to verify that the output of the adversarial framework generates a program that it's still malicious?
That's
So you run up, for example, we consider an app.
Yeah.
You run that in a sandbox and verify that it's still having an impact on the operating system, or
so one of the key principles of the adversarial framework is that all adversarial generated data, I'm not going to even say files, but all the data that we generate adversarially still has the same functionality. So we only change the way it looks, let's say, but we don't change the functionality. So for scripts, we can run the scripts in the sandbox and see that there's no parsing error, scripts are still running, we get the same results. Same for binaries like elfs, macros, these. That's the main goal. If that doesn't happen, we're wasting our time.
another question regarding the model sizes. They are so small. How do you manage to achieve this size? Do you reduce the features of that are considered by the machine learning model, or do you tweak the parameters of the model?
Both and some extra things. So the PE model, for example, that we deploy on sensor has a reduced feature set of what the cloud can do. So we look at the best features that we use in the cloud, best performing features, and we select those for the sensor. At the same time, we're leveraging the TensorFlow to Rust framework, where instead of deploying TensorFlow binaries and TensorFlow code, we actually transpile it to pure Rust code, so we don't have any of the boilerplate code that TensorFlow provides and any of the attack surface that code provides, and we are able to reduce the size for these kind of models significantly. I can't give any numbers because it really depends on the application, but we can reduce the size significantly. On top of that, there are other solutions like neural network compression.
Basically, the model itself.
Yeah, we can do. Yeah, exactly.
And one post start asking questions because I forgot to mention one thing. For each question you ask, you actually get a giveaway. Congratulations. Woo! So, your question.
So, making your model as robust as possible should catch all changes in feature. But have you thought about trying to catch changes in innovation? So instead of actually training on the entire data, train between generations of malware. Malware of 2016, right? You train your model and take it again 2017, and then do incremental updates. And try to catch also the evolution of the malware and several features.
Yeah, so we did do some experiments where we try to separate between train and test based on time. The problem is that that time is not. What happens is that some attacks works for some companies, other attacks don't work for other companies. So usually attackers try to reuse code. We like to think that they do the least amount of work in order to bypass a vendor. So what we are aiming to do here is make the cost for us very small in order to change our techniques so that we can detect the new attack, and at the same time increase their cost significantly in order to come up with a new update. But yeah, we tried that. It has limited gains. It doesn't work that well because, again, they change very little if they don't need to change too much. Sometimes like one simple SHA busting technique works. Just detects based on the SHA file. They just add one timestamp.
Yay, you get a prize. Yes, sir.
Curious, you brought up right at the end there that there's been a growing presence of malware evasion stuff in the open source community, or in various, sometimes just hosted on GitHub and questionably open source or not, but you know, the whole spectrum. And that's really true. And I wondered, what's your percentages like these days? I mean, I'm sure you have a large private library for your generation that's not stuff released on GitHub. I was curious what percentage that you're picking up from more freely available sources these days.
So I think we looked at these last time about a month ago. Were you the one looking, Ciprian? No. We looked about a month ago, maybe a month and a half, and we were only picking up like 3 ideas for injection faults or changes into the files. Everything else we already had covered. One thing we don't do is we don't look at the faults related or vulnerabilities related to the frameworks themselves, just because for once we deploy on sensors pure Rust code, so we don't use any of the third-party libraries for like TensorFlow or PyTorch or XGBoost or whatever. We use our own libraries. And then louder. And then in the cloud, again, doesn't really matter. It's in the cloud. So yeah, not a lot.
Not a significant.
Not a significant.
You get a prize. I'm being told there's a 5-minute break. No questions. We're going to take a 5-minute break, and then we'll come back to the second.
Thank you, everybody.
Sorry.
I smell pizza. No. I smell okay.
Pune zoom.
Really, beloved,